We're going to look at how to divide polynomials, and the standard procedure for this is long division, just like it is for numbers. And this can be useful in lots of ways, and we'll look at ways we can use this later. But you could use it for graphing rational functions because rational functions are division. You can find quotients and remainders, etc. So let's get started with a review of how to do long division in general. So let's say we want to divide 1273 by 8, okay? And we'll compare that side by side to, let's say we want to divide the polynomial 2x to the fourth plus x cubed minus 3x squared plus x plus 5 by x plus 2, okay? So we're going to work these side by side. So let's start with the numbers that we're familiar with. So we've got 1273 divided by 8. So we're going to set it up with 1273, which is our dividend. What's underneath the division symbol is the dividend, divided by 8, which is the divisor. Over here we've got 2x to the fourth plus x cubed minus 3x squared plus x plus 5 divided by the divisor x plus 2. Okay, so same setup. We've got dividend and we've got divisor. Okay. All right. So the process starts by the first thing you do is you divide, but you don't divide all of it. For example, if we knew how many times 8 went into 1273, we wouldn't have this process. So we don't divide all of it. We divide just the leading term. So I start by dividing 8 into 12, and 8 goes into 12 one time. And then after you do that initial division, then you multiply this 1, which is part of our quotient, right? Our quotient is the answer we get, how many times it goes in. So we multiply that answer by the divisor 8. So we take 1 times 8, which is 8, and I line it up under the 12. And then when after I multiply, then I subtract. Okay? So I take 12 minus 8, which gives me 4. And then what I have here is the start of a new dividend. So I've got the 4, and then I bring down the 73 that I had there. Okay, so you subtract and you drop the rest. And then you start over. This is a new dividend for 73. So we start over. 8 goes into 47 5 times. Then I take the 5 and I multiply by the divisor 8 to get 40. And I subtract to get 7. And I drop the 3 down here. 8 goes into 73 9 times. 9 times 8 is 72. Subtract, and I get 1. So we repeat all of this. We repeat until we can't divide anymore. We repeat until we can't divide. 8 is too big to go into 1, so we're done. And this 1 is our remainder. So this is our remainder. Okay? And again, the answer that we get up here, how many times it goes in, is the quotient. So we're going to talk about what we can do with this in a moment, but let's practice this now. I'm not interested in you dividing numbers, but this is to refresh your memory on the terminology and the process so that we can understand the long division of polynomials a bit better. So the first thing we do is we divide leading terms. So I just divide x into 2x to the fourth. X goes into 2x to the fourth 2x to the third times. Excuse me. That's because x times 2x to the third is 2x to the fourth. So that's the divide part. Then I take and I the current quotient, and I take my 2x cubed and I multiply it by the entire divisor here, x plus 2. So I have to distribute it to both terms. And when I do that, I get 2x to the fourth plus 4x to the third. And now I have to subtract all of this. And this, I'm going to put a star next to this third step. This is where most people mess up. Because I have to subtract all of this, I have to distribute the negative. So I'm going to switch colors here from blue to red, and I'm going to change this to a negative, and I'm going to change this to a negative, because I'm distributing that subtraction. Then, when I do the subtraction, I get 0, which is what I want. This first term should always cancel if you've done it right. And then x cubed minus 4x cubed is negative 3x cubed, and then I drop the rest of this. Minus 3x squared plus x plus 5. Okay? Then we start the process over. I take my leading term x, divide it into my leading term negative 3x to the third. And so what do you multiply x by to get negative 3x to the third? Negative 3x squared. Now I take my negative 3x squared and I distribute it to both terms of my divisor. And that gives me negative 3x to the third minus 6x to the second. And then I have to subtract. So I'm going to distribute the negative, which changes this to a positive and changes that to a positive. The first terms cancel because negative 3x cubed plus 3x cubed is 0. Negative 3x squared plus 6x squared is positive 3x squared. And then I drop my plus x plus 5. And I start over. X divides into 3x squared, positive 3x times. One thing I'll mention here that's kind of I take for granted, but when you're doing long division, it's very important you keep everything lined up, all of your terms lined up, otherwise you will get confused. All right, let's take the positive 3x and distribute it to both terms of our divisor again, giving us 3x squared plus 6x. And then we subtract, so I distribute the negative. First terms cancel. 1x minus 6x is negative 5x. And I drop my plus 5. Then I take my x and I divide it into my new leading term, negative 5x, which is just negative 5. Distribute negative 5x minus 10. Subtract and distribute, changing both signs. The first terms cancel, and I'm left with 15. Then I tried to divide x into 15, but 15 doesn't have an x in it at all. I can't divide x into 15 because 15 is too small. So this is my remainder. And so we've terminated the division process. Okay? So now let's talk about what we can do with these results. So I'll come back over here to the long division of numbers first. The way to interpret this is 1273 divided by 8, so 1273 over 8, equals a quotient of 159, and then the leftover part is our remainder, 1, divided by our divisor, 8. So this is a mixed number result. So 1273 divided by 8 gives us 159 and 1/8 left over. That's the same thing as, this is shortcut notation, but it's really 159 plus 1/8. So this right here is of the form quotient plus remainder over divisor. Okay? Quotient plus remainder over divisor. So that's a common way to interpret this result. Another common way is just to think of 1273, the original dividend. The dividend is broken down into two pieces, really. 8 times 159, because 1273 divided by 8 gave us 159 whole units. So that means 8 times 159 gets us close to 1273, and I've got a remainder of 1, so I just tack on the remainder. So if you multiply this out and add 1, you'll see that you do get 1273. So this is of the form dividend equals divisor times quotient plus remainder. So there's two different ways to interpret this division depending on what you're wanting to do. If you're focused on what the answer is when you divide, you get this. If you're focused on trying to break down your dividend, you might want to use the second version. Okay, so let's apply that over here to the polynomials. The first result would be 2x to the fourth plus x cubed minus 3x squared plus x plus 5 divided by x plus 2 equals the quotient. Let me see if I can get some more room here. Equals the quotient 2x cubed minus 3x squared plus 3x minus 5. That's our quotient. Plus the remainder, 15. This is the partial stuff that's left over. 15 over the divisor. Okay, so this is quotient plus remainder over divisor. Notice that the denominator on both sides is the divisor. That's always going to be the case to help you remember that. Now another way to write this is to break down the dividend. Okay, I'm kind of out of room here, but let me see if, yeah, I can fit it there. Our dividend, 2x to the fourth plus x cubed minus 3x squared plus x plus 5. Not the fraction, but the dividend itself can be broken down as x plus 2 times this quotient. Okay? X plus 2 times 2x cubed minus 3x squared plus 3x minus 5. But it won't give me exactly the dividend if I multiply these together, because I had a remainder of 15. So I just add 15 to both sides. And you can check this out. If you multiply these polynomials together and add 15, you'll get the original dividend back. So again, the first result is focused on the division. The second result is focused on breaking down the dividend. Okay? All right, let's try some more examples. Let's divide x cubed minus 7x plus 9 by x squared plus 4x minus 3. So, one really important thing when doing long division that's helpful for beginners. Once you get established, you won't have to do this, but when you're a beginner, you always want to make sure to include any missing term. So you see that this is missing an x squared term. So you want to make sure to include it when you set up your division. So what we're going to do is we're going to do x cubed, and then we're going to say plus 0x squared, because you don't have any x squared terms, but we need like a placeholder here. You'll see why that's useful. Minus 7x plus 9. Divided by, our divisor has no missing terms. I've got an x squared term, then an x term, then a constant term. So x squared plus 4x minus 3. And what I mean by missing terms is you start at the highest term, and then if there's any terms missing after that, you need to make them 0. Okay? All right, so we start the process by dividing the leading terms. X squared goes into x cubed x times. Then I distribute my x to all three terms of my divisor, giving me x cubed plus 4x squared minus 3x. You can see that because the 0x squared is here, my like terms line up perfectly, which is what we want to happen. If you didn't, then you'd have this negative 7x stacked on top of your 4x squared, which might throw you off in the next step when you subtract. And again, I'm distributing the negative because we're subtracting all of this. The first terms cancel. Then I get negative 4x squared, negative 4x, and I drop my plus 9. And I start over. Divide x squared into negative 4x squared to get minus 4. And then distribute negative 4 to all three terms of my divisor, giving me negative 4x squared minus 16x plus 12. Subtract this, meaning distribute and change all the signs. First terms cancel, and then I get 12x minus 3. Then I try to divide x squared into my leading term of 12x. But 12x has a degree of 1, which is too low for x squared to divide into it. So my remainder now is all of this. Okay, so our division is done. Let's interpret the results. So we take the first result is going to be the dividend divided by the divisor. So x cubed minus 7x plus 9 divided by x squared plus 4x minus 3. When we divide those, we get an answer or quotient of x minus 4. But there's some stuff left over, which is 12x minus 3 out of our divisor x squared plus 4x minus 3. Again, the denominators on both sides match. So we've got quotient plus remainder divided by divisor. That's one result. Or if we choose to focus on how to break down the dividend x cubed minus 7x plus 9, well, it's going to be x squared plus 4x minus 3 times x minus 4 plus what's left over, 12x minus 3 as our remainder. And so there's another example. This time our divisor had 3 terms, but the process is still the same. Let's do one more with more 0 placeholders just so we get confident with that. Let's divide the same dividend, x to the 4th minus 7x plus, let's change this one, x to the 4th minus 7x plus 9 by x squared plus 4. So now I've got x to the 4th plus 0x cubed plus 0x squared minus 7x plus 9. So I had 2 0 placeholders here because after my first term I was missing an x cubed and an x squared. My divisor is x squared plus 4. So I've got x squared plus 0x plus 4 because this guy's missing an x term. And now we start our process. X to the 4th divided by x squared is x squared. Distribute x squared to all 3 terms, giving us x to the 4th plus 0x cubed plus 4x squared. And then we subtract, changing all of those signs. First terms cancel. We get 0x cubed minus 4x squared, and we drop our minus 7x plus 9. X squared goes into the leading term 0x cubed, 0x times. 0x times all of this gives us 0x cubed plus 0x squared plus 0x. And we subtract that, which doesn't do anything except we drop off the first term, and now we get negative 4x squared minus 7x plus 9. So the 0 placeholders can add some work, but what they do is they help you stay very organized so you can follow the same procedure every time. Again, when you get better at this, you could try leaving all the zeros out and just combine the like terms even if they don't line up, which is the way I do it, but I've got a lot of experience with this. All right, x squared goes into the new leading term, negative 4x squared, negative 4 times. Then we distribute negative 4x squared minus 0x, because negative 4 times 0 is 0. And we've got minus 16. And we subtract, changing all the signs. First terms are 0, they cancel out. Then we get negative 7x plus 25. And now, because this degree of x to the 1st, it's a degree of 1, is smaller than the degree of 2 in our divisor, we're done. So x to the 4th minus 7x plus 9 divided by x squared plus 4 is x squared minus 4 is our quotient. That threw me off because it was so similar to the divisor. But our quotient is x squared minus 4 plus the remainder, negative 7x plus 25, over the divisor, x squared plus 4. Or, if we focus on how to break down our dividend, it equals x squared plus 4 times x squared minus 4 plus our remainder, negative 7x plus 25. Plus 25, sorry about the bad handwriting. And there are several examples of long division of polynomials. The only way to get good at this is to practice. Take your time, be neat, be organized. I even recommend changing colors when you distribute this negative, because that's the part everybody misses, because it's going to build some muscle memory, which can be extremely helpful. So go practice and see how you do.